So we're going to continue where we left off, and we're going to calculate the volume of this given shape with an odd base. Now this one's kind of like the one we just did in our homework, with the same exact shape in a way, but not a cone. So in your homework you had to do a cone, but the problem with this one, the numbers aren't there. It's variables. The thing about variables, they're numbers. They act like numbers. You treat them like numbers. So therefore you can add, subtract, multiply, and divide them like numbers, but if they're not the same base, then you cannot use your property of exponents. You kind of leave them alone or separated. Okay? So let's take a look at this object. I got to find the volume. And sometimes they give you the object and it's pretty obvious what should be the base, and sometimes it's not. Now if I'm looking at this, would I choose this bottom piece here, which would lay down this way, right? On the bottom, would I make that my base? The question you should be asking yourself, if I started on that bottom and I went up, so this looks like it's laying on the ground there. If I went straight up, would it be the same or continuously the same all the way up through that object? So as I'm coming up, I would have to almost go around this edge. It goes out and then comes back in, right? Is that staying the same, consistent? No. So I would not want to start on that bottom. So let's take that away. Think of it this way. Okay. Now, if I picked it up or picked up the front here and rotated it that way, and I made this my bottom or my base, it looks like I have a better chance. It looks like as I move this way, it's pretty consistent, right? Until I hit this end piece again. That end piece would start getting narrower and narrower and narrower until it hit the end, right? Kind of see that? Can you visualize that? If I took this piece, turned it upright, and went this way. Okay, or this way through the problem. That doesn't seem right. So which way should I turn it? Which way should I turn it? Or which way should be the base? Yeah, okay. No. Which way should it be turned so that I can be consistent all the way through the object? Where should the base be? The base, I think, is this front face that's facing towards us. It looks, again, like the basketball free throw area, right? If I continuously go through the object going backwards, it doesn't change, ever, through the whole problem. So therefore, that's my base. Now, it looks pretty obvious to us that maybe that should be it, but some of us need to see that. We need to see that we could approach this from different places, but we're going to stick with the one that's consistently all the way through, because I don't have a formula for the changing of that arc right there, that half of a circle or part of a circle, okay? Okay, what do I do? How do I find the volume of a shape? We just did this. We did this on Friday. We did this in our notes to our homework today that we just went over. What's the formula again? Volume. Base times the height. But the base really stands for the area of the base. So, how do I find the area of the base? What two shapes am I seeing? Rectangle and half a circle. That half a circle looks kind of funny, but it's there. What's the dimensions of the rectangle? 2x and 3x. Area of a rectangle is length times width. So I would think it'd be 2x times 3x, with 2x times 3x. 6x squared. Interesting. What is the area of a circle again? Pi r squared. Do we really want the whole thing though? How much of it want? Half. So I'm going to divide it by 2. What's R? Is it 2x? No, it's 1x. Or it's half because it's x and x over there. So the radius is x. So what is that going to look like? Pi x squared. And what do I need to do with those two? Add them together. There's my answer, right? Right there? Is that my answer? Yeah, we're done. No, we're not done. What is that again? The circle and the rectangle, but it's the what of it? Of this object, this given shape, it's the area of the base. We need to take that value and do what with it? Multiply times the height. What's the height? It's y. And then what should we do with that y? Distribute it. Now, hopefully you recognize there's an x squared in both of those as well. So maybe instead of multiplying the y through, could I factor off an x squared? So there's a couple different options here. But I would have y, or 6yx squared plus pi yx squared. And there's my volume. It doesn't give us units, so it'd just be units cubed, right? Now, what if I changed it up? What if I went like this and put a dot here? Whoops. And I formed a cone or a pyramid instead. So now I want the cone or pyramid given that base with that height. What do I have to do then?
Divide it by 1/3.
Not divide it by 1/3.
Oh, multiply
Multiply by 1/3. There's a difference.
Yeah.
Because if you divide by a fraction, you have to flip and multiply. It'd be multiplied by 3. So be careful. If you're going to go with the pyramid or the cone, you would take all of that and multiply by 1/3. The red's not part of this problem, so just go with the purple. But I'm just highlighting that they're all interconnected. That I could ask that one next step saying, if I found the volume of the prism, can I also ask you to find the volume of the cone with that same base and height? The answer is yes. Any questions? Surface area of cones. Surface area would be just the area of all sides added up. Yeah? So you just got to find the area of all faces, gather it all together. Nice things are is sometimes they're cubes, and if it was a cube, you just have to do it once, multiply by 6. If it's a rectangle, there's always a pair. So sometimes they go pretty fast, pretty simple. Slant height. Slant height sometimes is referred to the lateral height. Okay? So those words are going to be interchanged. This is the shortest distance from the apex to the base on a side. So when we're talking about a cone, it's actually, when you look at a cone, the slant height would just be the side of that cone you're looking at here. If I drew one down the middle, you would have to connect it to the top all the way to the bottom edge of that circle as well, because it goes all the way around. It's that slanted edge or the side of the cone. Okay? Don't get that mixed up with the altitude or the height that runs into the ground right below it. because that's the height of the cone, not the lateral height. Okay? Now, taking a look at the example there, I think there's only 2 examples left. It says that we have a radius of the base of a right circular cone, kind of like the one pictured above, is 8 centimeters. The slant height of the cone is 10 centimeters. Find the surface area of the cone. Now, I don't think we talked about the surface area formula for a cone. We talked about the volume, we talked about those things, but not the surface area. Well, if you take a look at the picture above, which is a right cone, circular cone, there are 2 pieces to it. I think everybody can see the bottom. Yes? That's a circle. We know how to find the area of that. That's just pi r squared. Can you guys agree with that? Now, when we took a cylinder apart, the can, we took the 2 circles on top and bottom. We had 2 of those. And then when we cut those off and then make a cut up the side of the can, we were able to lay it flat and it formed a rectangle, correct? You guys ever try to take a piece of paper and form a cone with it?
Yes.
Can you use a square or a rectangular piece of paper and make a cone and make it fit perfectly? No, you have overlap, right? There's always that small bit of overlap or sometimes large overlap on no matter how big your cone is. So you're not using up. It's not a true rectangle. When I open up or unfold the cone, so if I take a scissors, cut the top off, and cut down right to the tip of the cone and lay it flat, it kind of forms like a sector where it looks round on the bottom because that's the bottom where it goes around the circle. Okay? This should be a straight line right here. That'd be more of a straight line.
Oh, nice. What?
So, okay. So that's what it forms. Now, we didn't talk about the surface area of that. That actually is pi times the radius times L. And L stands for the lateral height, or slant height. Okay? Add those together, you get surface area, SA, of a cone. Oh, what's R? The radius of it was 8. So it's 8 squared plus pi times 8 and the slant height, 10 it says. And then just multiply them through. What's 8 squared? So 64 pi plus 80 pi, which will give me a total of 144 pi. What units are we in? Centimeters squared. Why is it squared, not cubed now? We're just talking about volume before, because we're talking about area. Last problem. Find the surface area and volume of a sphere. Radius 9 meters. Well, first of all, we just did a problem about talking about that volume in our homework last night. In all of the pictures from the last week's notes, we had a formula for the volume. And it's on the board as well right now. 2/3 pi r squared h, right? It's 2/3 the volume that the ball or sphere will fit into of a can. So again, I have that can where the ball fits inside there. And we talked about that if this is my radius can be turned up and down. So that's r, and your height is 2r. Sometimes you see the volume of a sphere as 4/3 pi r cubed. It's because I can take h and replace it with 2r. The 2 goes with the 2/3, and the r goes to r squared, makes r cubed. So we have 9. So V equals, if I change my numbers, The radius is 9 and 9, which makes the height what? 18. So it's 2/3 pi r squared, 9 squared, times 18. What's 9 squared? So it's 81 times 18 times 2/3, which ends up being, people take your calculators out, wouldn't be a bad thing, wouldn't hurt, 972 pi meters cubed, because we're talking about meters. And I think we gave the surface area formula, maybe not. Surface area formula, if we didn't have it, happens to be, I would definitely write this down, 4 pi r squared. So that's not too bad. It's 4 times 9 squared. Or 4 times 81, and put the pi at the end. 4 times 81 is 324 pi meters squared. So if we have the right formula, we're going to be fine. If you don't have the formula for surface areas on some of them, you're going to have to come up with it. Somehow build it. It's not the easiest for a sphere. But some of the others, you just piece together the parts or the faces that you see. Homework on Lesson 2, Day 3. It's page 24, 14, 21, 25, 26, and 28. Have a great day.